Another networking service in the cloud that we need to talk about are load balancers. And a load balancer is a device or service that distributes incoming network or application traffic across multiple servers. So by spreading the request load among several servers, it ensures no single server is overwhelmed with too much demand, and thus that improves the responsiveness and availability of applications. Now, if you can see in this diagram, this provides a detailed depiction of how a sophisticated load balancing mechanism can function. So first, a user initiates a request to access a web application, and that request is sent from the user's device, like a computer or a smartphone, to a client interface, which might represent a user's browser or application. Now, before reaching the load balancer, the client's request is first directed to a name server, and the name server typically resolves domain names into IP addresses. Now, once the IP address is resolved, the client's request is routed to the load balancer, and within the load balancer, the request first goes through a classifier and a scheduler. So that component determines the nature of the request and decides how it should be processed, and the dispatcher then takes this classified request to decide which server should handle it. Now, the supervisor appears to oversee this process, ensuring that decisions made by the dispatcher align with the system's overall load balancing strategy and that servers are not overwhelmed. Now, before making a decision, the dispatcher communicates with load calculators associated with each web server, and these calculators provide real-time data about the current load or traffic on each server. So by considering this data, the dispatcher can make an informed decision about which server is best suited to handle the incoming request, ensuring that traffic is evenly spread and no single server is overloaded. And once the dispatcher decides on the most appropriate server, it routes the request to the specific web server. It could be server 1, 2, 3, or whatever it is. Now, the chosen server then processes the request and sends back the response, which gets routed through the load balancer and back to the client. So throughout this entire process, the aim of the load balancer, as depicted in here, is to ensure that incoming requests are efficiently and fairly distributed among available servers based on their current load, resulting in optimized performance and minimized server downtime.